What's up, everybody, and welcome back to Algebra and Trigonometry, Chapter 2, Section 1, the rectangular coordinate systems and graphs. Let's do it. Is it possible for a point plotted in the Cartesian coordinate system to not lie in one of the four quadrants? Explain. This is possible. The way this is possible is if we look at the Cartesian coordinate system, we have a y-axis and an x-axis, right? So the x comes across, the y goes up and down. So if, for example, a point is out here, it's in the first quadrant. Here it would be in the second quadrant. Here it would be in the third quadrant. Here it would be in the fourth quadrant. The exception to being in one of the quadrants if it lied directly on one of the axes. So for example, if it was on the x-axis, it wouldn't be in any quadrant. Likewise, if it were on the y-axis, it wouldn't be on any quadrant. Describe in your own words what the y-intercept of a graph is. So again, if we look at our x, y axes, right here is the x-axis, here is the y-axis. The y-intercept of a graph is where this function hits the y-axis, so it'd be right here. Or if it was just a straight linear function, boom, it would be, again, right where it hits the y-axis. So that's your y-intercept. So for number 5, we're supposed to find the x-intercept and the y-intercept without graphing. So the nice thing about this being in slope-intercept form, which it is that we can easily see the y-intercept in the equation. So the y-intercept is the b value, which in this case is 6. And I want it in the coordinate of the intercept. So this is the y-intercept. So the y-intercept would be written as 0, 6, because the y-intercept is always going to have an x value of 0. That's how we know it's on the y-axis. Now, to find the x-axis, the x-intercept, we would actually now have 0 for the y value. So I'll write it out and start it out here. So 0 would be for the y value. That's how we know it will be on the x-axis at that point. So how do I solve for that? I plug in 0 for y and I solve for x. So then I'm going to subtract 6 from both sides. And I get negative 6 equals negative 3x. Divide by negative 3. Boom, boom. And x would equal 2. So it would have an x-intercept of 2, 0. This one's going to be a little easier to find the x and y intercepts because, in fact, we know once again that the y-intercept has a 0x value and the x-intercept has a 0y value. So check this out. In this one, I can quickly plug 0 in for x, and that just knocks this out. Then I have negative 2y equals 6, divided by negative 2, and y would equal negative 3. Likewise, to solve for the x-intercept, I plug 0 in for y, which basically zeroes out that term. Divide both sides by 3, and x would equal 2. So the x-intercept is 2, 0. The y-intercept is 0, negative 3. So once again, to find the x-intercept, I'm going to plug in 0 for y. So if I zero this whole thing out and divide both sides by 3, my x-intercept would be 3, 0. To find the y-intercept, now I'm going to plug 0 in for x, which would zero out this term. Then I divide both sides by 8, and my y-intercept would be 0, 9 eighths. So here we are solving the equation for y in terms of x. That just means to isolate y. So we're going to use variable isolation. I'm going to start by subtracting 4x from both sides. And that gives me 2y equals negative 4x plus 8. So I'm choosing to put the negative 4x in front of the 8. It really doesn't matter. The only reason why I like to do this is because then it comes out in slope-intercept form. Then I'm going to divide everything by 2. And I get y equals negative 2x plus 4. Boom, done. So the first thing I'm going to do is I'm going to subtract 5 from both sides to get rid of that there. Then I have negative 3y equals 2x minus 5. Again, I've switched the sides of the y and the x in the other terms. It doesn't really matter, but I just do that because I'm more comfortable that way. Then I'm going to divide everything by negative 3. And we get y equals 2x minus 5 over negative 3. Boom, done. First, I'm going to subtract 4 from both sides, and that gives me 5y equals 10x minus 4. Last step, I'm going to divide both sides by 5, and we get y equals 10x minus 4 over 5. Boom, done. Now you'll notice in the answer in the back of the book, they've actually broken this up into 2 terms. It's kind of arbitrary. They didn't tell you to do that. So you can kind of, like, they left it like this sort of in the last one. But if you want to further simplify it, you're just dividing each term by 5. So it becomes y equals 2x minus 4/5. But both of these answers are perfectly acceptable. To find the distance between 2 coordinates, we need to use the distance formula. So the distance formula is as follows. we take the difference of the x values, okay, so it would be -4 minus 3, and we square it. Then we add that to the difference of the y values like this. And again, I'm going kind of like left to right. It doesn't really matter, but I'm going 1 minus -4 and squared, and there we have it. So this becomes -7 squared is 49 positive. This becomes a plus, so 1 plus 4 is 5 squared is 25. 49 plus 25 is 74. And that can be broken up into 2 times 37. Neither of those are perfect squares, so this is the final answer. Done. So again, we're going to use the distance formula, though you don't really need it in this case because you can see that the x values are the exact same. And it's really just the distance of the y values is the distance. But let's use the distance formula just to get more practice. So we're taking the square root of first the difference of these x terms, 5 minus 5 squared, plus the difference of the y terms, that is 0 minus 6 squared. So this is, of course, 0, because 5 minus 5 is 0. 0 minus 6 is -6 squared is 36, and the square root of 36 is 6. Boom, done. In this one, it's the exact same thing. We're just going to now use a calculator to get an approximation. So check it out. We're going to use the distance formula. I'm going to take the difference of 19 and 41, aka the difference of the x values, square it, add it to the difference of the y values, 12 minus 71, square it, and we're going to plug this into a calculator. But first, let's simplify it as much as we can. 19 minus 41 is -22 squared, and 12 minus 71 is -59 squared, like so. So as I type it in, I'll do just 22 squared because it doesn't really matter, because if we are squaring a negative, it becomes positive anyways. And this plus 59 squared, and all of this we're taking the square root of eventually, so we got the parentheses there, and boom, and we get our answer, 62.968, and they want us to round that to the nearest hundred, so it would be 62.97, 62.97, boom, done. In this question, we're asked to find the midpoint of these two. So the actual formula goes like this. We take the average of the x values in the x spot. So it's -1 plus 7 divided by 2, comma, the average of these y values. So 1 plus -4 divided by 2. And what we end up getting is 6 over 2, which is 3. And we get -3 over 2, which will leave as an improper fraction. That's how we do it. The other way to think about it is what is exactly between -1 and 7? That's 3. It's 4 away from each. What is exactly between 1 and -4? -1.5, because it's 2.5 away from each. So that is the winner. Done. Here we're going to use the midpoint formula again. So we're going to take the average of 0 and 4, the x values in the x spot, and then take the average of 7 and -9 in the y spot, because those are the y values. So that's 4 over 2, which is 2, -2 over 2, which is -1. Boom, done. What are the coordinates of the origin? So first of all, what is the origin? If we look at our xy axis, the origin is right here. It's the point where the x and y axis intersect, and that's actually our ground 0, and the coordinate is 0, 0, because you're going a distance of 0 left or right on the x-axis, and you're going a distance of 0 up or down on the y-axis, so 0, 0, boom, done. If a point is located on the x-axis, what is the y-coordinate? So again, let's take a look at a quick x-y axis. So here's x, here's y. So on the x-axis is right here. So what would be the y-coordinate? Well, here's the thing. The y-coordinate indicates how far up or down it's going from the x-axis, from the ground 0 in terms of going up or down. Well, if it's on the x-axis, it's at ground 0, aka the y-coordinate value is 0, regardless of what the x is. Like in this case, the x could be 4 or something like that. So the y-coordinate is 0, boom, done. Here we're just meant to plot these 3 coordinates and then see if they're collinear. So -1, 2, I would go -1, so starting at the origin, left 1, and then up 2. So there's -1, 2. Again, you see this is my x value, this is my y value. 0, 4, I start 0, going no distance left or right, and then going up 4 on the y-axis. And then here's 2, 1, so I go to the right 2, positive 2, and then up 1 because it's a positive 1. So I would say these points are not collinear because I cannot draw a single line through all of them. I could draw a line through 2 of them or 2 of them, but not through all 3 at once. Boom, done. So for 33, we have to name the actual coordinates for A, B, and C. So here it's -3, 2. The reason why is A is 3 to the left of the origin, and then you go from that point up by 2. For B, we're going out by 1, up by 3, so that's a coordinate of 1, 3. And C, we're going out 4, and we're not going up or down at all, so it's 4 for the X and 0 for the Y. Boom, done. All right, so for this exercise, it's asking us to construct a table and then graph the equation by plotting at least 3 points. So the way we can do this is actually there's a lot of different options. I'm going to do it in the easiest way I can think of possible. So I'm going to choose 3 random X values that are going to fit nicely on this graph. And I'm going to do it in a way where I'm not going to get fractions as results because I see this 1/3 and that's going to be messy to graph a fraction. So the first coordinate I'm going to choose is -3 because -3 times 1/3 is -1. Plus 2 is +1. Again, did I need to do -3 or do I need to not have fractions? No, I'm just doing this to make life easier on myself. Then I'm going to choose 0, and if I plug in 0, this whole thing zeroes out and I get 0 plus 2 is 2. Lastly, I'm going to plug in 3 here, and 1/3 times 3 is 1 plus 2 is 3. So check it out. I'm going to plot these 3 points. So I got -3, +1, 0, +2, 3, +3. So now I've got these 3 points, and I'm going to just thread them with a nice line. I got arrows on both ends to indicate that it goes on forever in either direction. There we go. Boom, done. Here we're going to do the same thing and get 3 points and then plot them. I'm going to leave it like this. Now, what I'm going to do, again, to make life easy is I know that I'm multiplying 2 by my Y value. So I'm trying to get even numbers on the right-hand side, and that way it'll be easy to get my Y value. So watch. I'm going to try 1 for X, and that would give me 1 plus 3, which is 4, equals 2Y. Therefore, Y would equal 2. Next, I'm going to plug in 3 for X. 3 plus 3 is 6. 2Y equaling 6 would mean that Y equals 3. See, we're just solving for the Y value. And then I'm going to plug in 5 for X. 5 plus 3 is 8. That would mean 2Y equals 8, so Y would equal 4. So now I got 3 nice points. I got 1 X 2 on the Y, so that's there. 3 out, 3 up, and then I got 5 out, 4 up. And you know you've probably done it right when you see that they form a nice line like that. So now we're just going to connect the dots like so, and there's your line. Boom, done. All right, so for 39, we're going to find the X and the Y intercept. So the nice thing that it's in standard form, my X intercept is going to be where Y equals 0. So I can basically zero that out, and X will equal 8 when Y is 0. For my Y-intercept, my X value is going to equal 0. So I basically zero this out. -2Y equals 8 divided by -2, and we get -4. So now my 2 points would be here, and 0, -4 is down here. And this is just another method that we can use to plot in a linear equation. So now I just connect the dots. Boom, boom, and there's your line. So here to find the X-intercept, again, I'm going to plug in 0 for Y. And to find the Y-intercept, I'm going to plug in 0 for X. So check it out. If I zero out the Y here, I get -2X plus 6 equals 0. Subtract 6 from both sides. -6 equals -2X. Divide both sides by -2, and I get X equals +3, right? -6 divided by -2 is +3. Now to find the Y-intercept, I'm going to zero out the X, so that goes away. I get 3Y equals 6, divide both sides by 3, Y equals 2. Boom. So now my 2 points are at 3, 0, so I go out 3, there's my X-intercept. My Y-intercept is 0, 2, so right there. And then I connect the dots, there's my line, boom, done. All right, so what we're supposed to do is to find the distance of the 2 endpoints. So first, let's figure out what these coordinates are. So I can see it goes to the left by 3 and up by 4. So my coordinate of this endpoint is -3, 4. And here it goes out to 5 on the x-axis, and it's 2 on the y-axis, so 5, 2. So now I use my distance formula. So we take the difference of the x values, -3 minus 5 squared, plus the difference of the y values, 4 minus 2 squared. So -3 minus 5 is -8. 8 squared is 64. And then 4 minus 2 is 2 squared, which is 4. 64 plus 4 is 68. And we can simplify that because 68 is 4 times 17. The square root of 4 is a nice perfect 2. So this gives me a simplified answer of 2 rad 17. Now they want the approximation rounding to 3 decimal places, so we use our calculator. 2 times the square root of 17 gives us 8.246. 8.246 is the winner. Done. Here we want the distance of negative 3, 4 to the origin. So negative 3, 4 is this point right here. And we want the distance of this to the origin. Again, the origin is 0, 0. So using the distance formula, we can say it's the difference of these two x values, which is negative 3 and 0, right? Because the origin is 0, 0. So negative 3 minus 0 squared plus 4 minus, again, it's 0 for the y value squared. So that's basically just negative 3 squared, which is 9, plus 4 squared, which is 16, square root of 25, which is 5. Boom, done. Okay, lastly, they're asking which point, this point or this point, is closer to the origin. So we know that negative 3 comma 4 has a distance of 5. So what about this point, which is 5 comma 2? So let's check it out. So we're going to, again, use the distance formula with the origin of 0, 0. So we're going to take the square root of 5 minus 0 squared plus 2 minus 0 squared. So that's the square root of 5 squared is 25. 2 squared is 4. Square root of 29. So the question is the square root of 29 larger or smaller than 5? It's actually larger because the square root of 25 is 5. This is bigger than the square root of 25. So this point is closer. Boom, done. For this question, we're trying to find the y-intercept of this function. Now, it's given with instructions to put this into a TI-84 or something like that, Texas Instruments calculator. I'm going to actually show you how to do this on Desmos instead, because everybody has access to Desmos nowadays. So the function is y equals 3x minus 8, and we're going to put this in parentheses because we're going to divide the entire thing by 4. And now it's really easy on Desmos, which is why I love Desmos, to see where the y-intercept is. It's just where it hits this y-axis, and it's at 0, negative 2. So the answer for the y-intercept is 0, negative 2. Boom, done. For 51, we're trying to find the x-intercept. Again, I'm going to use Desmos instead of a Texas Instruments calculator. So y equals negative 8x plus 6. And to find the x-intercept is really cool because you can see it kind of already creates a point for the y and the x-intercepts. Here's your x-intercept, and it's at 0.75 comma 0. So 0.75 comma 0, boom, done. So for this one, it's y equals 3x plus 5 over 4. We're going to round to the nearest thousandth. So there's our function, 3x plus 5 over 4, and the x-intercept is at negative 1.667 comma 0. So we have negative 1.667 comma 0, boom, done. So 55 refers back to 54, so we're going to read that first. A man drove 10 miles directly east from his home, so we're going to indicate that by going to the right, and then made a left turn and went 5 miles north, like so. So the question is, if we make a road straight diagonal from here to here, how much shorter would the man's one-way trip be every day? As of now, the trip is 10 plus 5 is 15 miles, right? We're going boom and then boom. Here, it's going to be a hypotenuse of a right triangle, which we can use Pythagorean's theorem, which is basically the same thing as the distance formula. So we're going to calculate that distance as 10 squared plus 5 squared equals c squared. That's 100 plus 25, which is 125 equals c squared. We can take the square root of both sides. And I'm going to actually use my calculator to get an approximation so we have a better idea of exactly how much shorter this is. So the square root of 125 is 11.18. I'm going to round that up to 11.2. So how much shorter is this? We could subtract them, but you could do it mentally. 15 minus 11.2 is 3.8 miles. Boom, done. So 57 refers to 56, so we're going to keep that up there as we go. So it says, given these 4 points, find the coordinates of the midpoint of line segments AB and CD. So I'm going to plot these points. So A is 1, 3, and B is negative 3, 5. So here is A, B. C is 4, 7, and D is 5, negative 4. So see, I can go 5 out, 4 down. So let's say this is C and D. Okay. Now we want to find the midpoints. Again, you can use the midpoint formula here, but we can also see it pretty clearly visually. My midpoint here is that point. It's exactly in the middle of these 2 points. But again, if you take the average, 1 plus -3 is -2, divided by 2 is -1. That's what we show there. And then you can see it's 4 here, but we take the average of 3 and 5. That is indeed 4. This midpoint is pretty obviously right here, but we're going to double check using algebra again. So to check this algebraically, we take the average of 4 and 5, and that is 9 divided by 2, which is 4.5. And for the y value 7 and -4, we add those together and get 3 divided by 2 is 1.5. So there we have the coordinates. Now we want to calculate the distance of these 2 midpoints. We're going to go back to our distance formula like so. So we take the difference of the x values, -1 minus 4.5 squared, plus the difference of the y values, 4 minus 1.5 squared. And I'm going to use a calculator to calculate this. So first, -1 minus 4.5 is -5.5. So we've got 5.5 squared. Again, because I don't care that it's negative. If you square a negative, it turns positive anyways. And then 4 minus 1.5 becomes 2.5. So we go 2.5 squared. Boom. And we get 6.0415. I'll round to the nearest thousandth. So like 6.042. So 6.042 for the win. Done. In the previous exercise, find the coordinates of the midpoint for each diagonal. So we're trying to find the middle point of each diagonal, but it looks like the midpoint is going to be the same for each. It's where they intersect. And that we know to be true because this is a rectangle. And guess what? The diagonals of a rectangle, they bisect each other, meaning where they intersect is the midpoint for both. So what is that midpoint for both of the diagonals? It looks like it's at 2, 2. So 2, 2. Boom, done. All right, so to do 61, we need the information here for San Francisco in 60. So it says the coordinates are 76, -12 for San Jose, and each coordinate unit represents a mile. And San Francisco is 53, 17. Find the distance. So what are we doing? We're using the distance formula. So we're going to take the square root of the difference of the x value, so 76 minus 53 squared, plus the difference of the y values, -12 minus 17 squared. And then 76 minus 53, that's 7 plus 16 is 23 squared, plus that's -29 squared. And then we're going to use a calculator. Square root of 23 squared plus 29 squared. Again, I'm omitting the negative because the negative squared is positive anyways. And then we get 37.0135, but they said to the nearest mile, which means we can go with 37 miles. Boom, done. A man on the top of a building wants to have a guy wire extend to a point on the ground 20 feet from the building. To the nearest foot, how long will the wire have to be if the building is 50 feet tall? So we've got a building that is 50 feet, and he wants it to be 20 feet from the building, so it's out here. So the wire would be like this diagonal, and guess what? Once again, we can use the distance formula, but as I mentioned in an earlier problem, this is basically the same as Pythagorean's theorem. Distance formula is Pythagorean's theorem, so we're going to apply that. So we got 50 squared plus 20 squared, a squared plus b squared equals c squared, where c is my length that we're trying to find. So 50 squared is 2,500. 20 squared is 400 equals c squared. C squared equals 2,900. And to solve, we take the square root of both, and c equals, using our calculator, square root of 2,900, which is 53.8516. So 54 feet for the win. Boom, done. I hope you enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.